Good day! In this video, we will be talking about integration, specifically this kind of situation. Let us now dive into the problem. Liza drove a car such that its acceleration in km/h squared is a equals to negative 45 quantity 2 plus 3t raised to negative 2, where t is in r's. Find the velocity as a function of time if v is equal to 3 after 1 hour. To be able to solve the problem, we first have to know which process to use. Since the given is acceleration, and we have to find the velocity as a function of time, therefore we will be using integration. Also, v is equal to the integration of a dt. After that, we have to know the u between the numerator and denominator from the expression. If we derive negative 45, we will come up with 0. But if we derive 2 plus 3t, then it will be more efficient since we will get 3. Therefore, we will use 2 plus 3t as the u with du being 3. To substitute negative 45, we will then use negative 15 du. Now, substitute the values from this expression. Negative 45 will now be negative 15 du, and 2 plus 3t squared will be u squared. We can now move negative 15 outside the integral symbol and use the exponent form of 1 over u squared, which is u raised to negative 2. We can now proceed to integration using u substitution. The rule is if we have the integration of u raised to n times du, it will be equal to u raised to n plus 1 over n plus 1 plus c, or the constant. Continue the process, and from here, change u raised to negative 1 to 1 over u, and cancel out the negative sign. Multiply 15 to 1 over u, and substitute u with 2 plus 3t. We now have v equals to 15 over 2 plus 3t plus c. We now have to find the value of c using what was given to us. Substitute v with 3 and t with 1. The value of c is 0. From the expression we have solved, substitute 0 with c, and we get the velocity as a function of time, which is v equals to 15 over 2 plus 3t. These are the steps if you encounter a similar problem to this, such as finding the expression through integration. First, know the process. Second, you must decide for the u, then solve for du. Third, substitute the values with your decided u and du. And fourth, integration by u substitution. Fifth, find the value for the constant using the values given in the problem. And sixth, substitute the values of c to the solved expression. In this way, we may be able to find the expression as a function of time or any other factors.